So today we're going to be going over the semester one final for geometry. Um, so let's go ahead and get started. This might take a little bit longer than usual because of the length of problems, but shouldn't be too terribly bad. So it says points A, B, C are collinear and arranged in that order. If AB is this and BC is that and AC is that, find the length of AB. So length meaning we want the actual length of the segment. So let's first start by drawing a diagram. So it says A, B, C are collinear, which means they make a line and arranged in that order. So we'll do point A, line, point B, line, point C. So they're in a line and they're in that order A, B, C. And it says AB is 2x plus 15. So here's 2x plus 15. And BC is 7x minus 3. So here's 7x minus 3. And it says AC, so the entire thing is 48. And it wants how long AB is. Not what X is, but how long AB is. So what we do is set up our little equation here. So we know that each of these segments together make the entire length. So if I take AB, which is 2x plus 15, and I add it to BC, which is 7x minus 3, that should get me the entire length, which is 48. So this piece plus this piece is the entire length, which gives me 48. And then it's just back to algebra and solving the equation. So add your x's and your non-x's together. So that'd be 9x, 2x plus 7. And then 15 plus negative 3 would give me 12 equals 48. Then we subtract 12 from both sides. We get 9x is equal to 36. And then we divide both sides by 9. And we get an answer of x equals 4. Now we don't want to circle 4 because that's what x equals, but they want the length of AB. So if AB is 2x plus 15, they want me to do this and plug the x back in there to get the actual length of AB. So I want this to be plugged back into where the x is, and then I get 8 plus 15, which gives me 23. So that's the length I want right here. 23. So if they ask you for the length, don't forget to plug it in. If they just said find the value of x, then we could circle 4 and be done with it. But they wanted the length of AB, so we have to find the length of AB. So don't forget to plug it back in if they ask you for the length of a segment. This one here, they give us a diagram to go off of. It says if the measure, so M there stands for measure. If the measure of CBA is 73, so CBA, so this entire angle is 73 degrees. And it says the measure of CBD is 52. So CBD is 52. What's the measure of ABD? So we don't know this measure ABD, so we can put an X there because we don't know what it is. So just like with segments, angles add together as well. So this angle plus this angle is going to get me the entire angle. So I know that X plus 52 is going to get me 73. And from here, again, just go back to algebra. I can subtract 52 from both sides. And I get x is equal to 21, which I believe I made an error when I first printed this, but this answer should be 21, not 11. So that would be the answer there. That's just a little misprint on my part. A little too fat-fingered button press there. So your answer in this case would be 21 because it's the entire angle minus what you have to get what you need. So for the first two, if they don't give you a diagram, make sure you draw your own out. But if they do give you the diagram, make sure you use that. And it's all a matter of setting up your equations. So the two small pieces have to add it together to get the big piece, and then whatever your x is, solve for that. So find the distance. So a distance problem requires a distance formula. So the distance formula, if you don't remember, is the following. It is x1 minus x2 squared plus y1 minus y2 squared, all square rooted. So the y1, the x2, the y2, the x1, those all represent your point values. So right here, we can call this x1, y1, x2, y2. It might be helpful to label them first just so you don't get them in the wrong order. So we set up this little square root thing here. X1 would be -2, whoops, not comma, minus x2 would be 8, plus y1, which is 5, minus y2, which is -4, making sure we put that negative in there for the 4. Then we do our arithmetic. So -2 minus 8 is -10 squared, plus 5 minus -4. Again, if you have a double negative, this turns into one big plus. So it's actually 5 plus 4, which is 9. We square those numbers, so -10 squared is 100, and 9 squared is 81. Be careful on this step, because what a lot of people do when they make a mistake is they type in this. So on your calculator, if you type in, let me clear this here, if you type in -10 squared, the calculator is going to tell you -100, because it's doing -10 times 10. That's what the calculator is doing, and that gives you 100. What you want is you want this, -10 squared. So don't forget to put parentheses around there, because that will give you the positive 100. Because you want -10 times -10, because you want to square the negative as well to get a positive answer. So after you square your numbers, you should only have positive numbers left here. If you have a negative number, go back and check. You add them together and you get 181. And then we square root 181. So again, on your calculator, that's second square root 181. And we end up getting 13.45, which would be this one right here, 13.45. So that's the distance formula. The midpoint formula is similar, but slightly different. The midpoint formula is when you have a point that you're trying to solve for, because it's the midpoint. So you're not trying to find a single number in this case, you're trying to find a point. And the way that goes is it's x1 plus x2, not minus, but plus x2 divided by 2, and y1 plus y2 divided by 2. It's an x there. So for midpoint, you add them and divide by 2. For a distance, you're subtracting them. They're very easy formulas to mix up, so again, might be something to put on a note card. Also, you could just think of this as finding the middle of your x's and finding the middle of your y's. The way you find the middle of two numbers is you add them and then cut them in half, which is what we're doing here. So in this case, I would do, again, we can call this x1, y1, x2, y2. So x1 is 2, x2 is 12 over 2. And then y1 is 6, y2 is -8, so plus -8 over 2. We do some arithmetic here. That's going to be 2 plus 12 is 14, divided by 2 is 7. And then 6 plus -8 is -2, divided by 2 is going to give me -1. So we have 7, -1 as the midpoint. So if these were on a graph, the midpoint between them would be 7, -1. So again, midpoint, you're looking for a solid point with two numbers. For a distance, you're just looking for a single number answer, which in this case was 13.45. Just to make sure I write it down there. So similar formulas, again, make sure we don't mix them up so that we don't miss easy points. These are just, again, kind of definition-y questions. So you're going to assume that these two lines here are parallel. Okay, you always assume that these two are parallel, otherwise none of these would work. And you want to figure out what kind of angles are they. So first off, vertical angles we know form that X shape, right? So these two would be vertical, and these two would be vertical. Well, X and Y don't share an X. They're not even in the same little grouping there. So it definitely can't be vertical because they don't make an X shape. Consecutive interior means that the two angles have to be in between the lines. So if these are my lines, interior angles are angles inside this space here. They have to be in between the lines. Well, Y is outside of the lines, so it can't be interior, because even though X is, Y is not. So it can't be consecutive interior, because Y is outside. Alternate interior, again, same reason, interior. Well, Y is not interior, so therefore it can't be alternate interior, which means it has to be corresponding. The way you can check corresponding, remember, is corresponding angles are in the same position. So if I have this picture here, actually, let me just use the picture they give me. That might be easier to show. So using this picture here, if you look at this set of 4 angles here, and this set of 4 angles there, y and x are both in the same sort of quadrant. So y is in the upper left quadrant, x is in the upper left quadrant, therefore they're going to be corresponding. So corresponding angles have to be in 2 different sets. So y is in this set of 4, x is in this set of 4, and they have to be in the same quadrant. Y over here, x over there. So both in the upper left-hand corner. So this angle and this angle would also be corresponding. This and this would also be corresponding. And this one and this one would also be corresponding. So x and y are corresponding angles, which again, you can also get just by process of elimination. They don't make an x. Y is not interior, so it can't be either of those. Therefore, it has to be corresponding. This one, again, same issue. Let's see here. Well, they're not corresponding because as we just said, if we make a little box around x, make a little box around y's, y is in the lower left-hand corner, x is in the upper right-hand corner, so they definitely can't be corresponding because they're both in different corners there. So we can't use that. Vertical, again, they don't make an X shape because they're disconnected, so it can't be vertical. Alternate interior and consecutive interior. Well, they're both interior, so both of these are possible. Alternate means they're on different sides of the transversal, which means that if X is on the left side of the transversal, which is the line that's cutting through the 2 other lines, so this right here, this is our transversal. If X is on the left side, then Y would have to be on the right side in order to be alternate interior, because then they'd be on different sides or alternate sides, and they'd be inside the 2 angles or 2 lines, so it'd be alternate interior. Unfortunately, Y is not. Y is on the same side as X, so Y and X are both on the left side of the transversal. So that means they have to be consecutive interior, also known as same side interior is another word for it. So again, consecutive means one after another. So if you're looking at this picture here, you have Y and then X, one after another. They're not switched across each side, they're just right in a row. So think if your variables are in a row, it's probably consecutive interior or exterior. Okay. So again, alternate means they have to be on different sides. The last one here, as we just said, we can probably think about this too. Again, vertical, they don't make an X shape. Corresponding, again, if we box in our Y, box in our X, X is in the upper left, Y is in the lower left, so it's not corresponding. So it has to be either, whoops, try that again. It has to be either consecutive or alternate. So in this case here, X is on the left side of my transversal. Again, here's my transversal because it cuts through the other 2 lines. So X is on the left, Y is on the right, so that would mean that they're alternate interior. They're both in between the 2 lines, so they're interior. X on the left, Y on the right, alternate interior, not consecutive. So different sides, alternate, same side, consecutive. If you just follow that rule, we should be okay. So now we're going to use those properties to find the values of x. So in this case here, we want to figure out what is the value of x. Well, if we notice here, if we trace these angles, like if I start at the end of this angle, so this angle goes from here all the way to there, and this angle goes from here all the way to there. So if I encompass all the angles here, we get a half circle. And a half circle we know have to add up to 180 degrees. So these 2 angles have to add together to get 180 degrees. So it look like x plus 10, which is angle 1, plus 3x plus 2, which is angle 2, has to equal 180. Or you can also know that these are a linear pair. So another way people look at this is they say that, let me try that again. Is they say that these 2 angles, when put back to back, they form a straight line on bottom. So they form a straight line down here. And straight lines are always 180 degrees, so therefore the 2 angles together have to be 180 degrees. They're called a linear pair because they're side by side and they make a nice straight line down on the bottom. But once we know that they make a half circle or that they make a straight line, we can go ahead and solve it using algebra. So x plus 3x is 4x, 10 plus 2 is 12, equals 180. Subtract subtract 12 from both sides. We get 4x is equal to, if we take a moment here, 180 minus 12 is going to get me 168. And then we divide by 4. And we get x is equal to 42, which is this right here. So when you see a side-by-side shape like this, again, the way we talked about this was that they make a Y shape. So if I outline this, it kind of makes kind of a sideways Y. So you kind of see a Y shape there. That means that they're going to add to 180 because they're a linear pair. So Y shape is the 180. This next one here makes the X shape, right? So if I outline this angle here, and this angle here, they make this sort of X pattern. And that means that they're vertical. So these are vertical angles. And we know that vertical angles are always equal to each other. Not equal to 180 necessarily, but equal to each other. So this will be written as 3x plus 1 equals 52. So in this case here, we're going to solve this by, again, using algebra. So once again, top angle, bottom angle are equal to each other. So minus 1, we get 3x equals 51. Divide by 3, we get x is equal to, in this case, 17, which is right here. So vertical angles are equal to each other, so they equal each other. Linear pairs are equal to 180, which is where I get over here. So X shape is equal to each other, Y shape is equal to 180. Here, again, this is going back to what we did before. So these angles, again, this is my transversal because it's cutting two other lines. And these angles are alternate because they're on different sides of the transversal. So one's on the left and one's on the right. And if they're alternate interior, because they're both inside the lines, or if they're just alternate in general, all alternate angles, they're going to be equal to each other. So 22x minus 5 is equal to 20x plus 7. So just like with vertical angles, alternate angles are going to be equal to each other. So what we can do here is we subtract 20x from both sides. We get 2x minus 5 is equal to 7. We add 5, and we get 2x is equal to 12. And divide by 2, and we get x is equal to 6, which is this one right here. So alternate interior angles are going to be equal to each other. Again, alternate meaning on different sides, interior meaning between the two lines. So they satisfy both conditions, so they're going to be equal to each other. Number 11, I'm going to erase this just so I have some room to work here. Number 11 is consecutive interior. Because again, there's one right after another. They're both on the they're both on the right side of the transversal. So here's my transversal. They're both on the right side. So they're not going to equal each other, but they are going to add to equal 180. They're supplementary. So 7 plus 12x, angle 1, plus 4x plus 13, which is the second angle, is going to equal 180. So consecutive angles are always going to add to equal 180. Alternate angles are just going to always equal each other. So if I solve this using some algebra here, 12x and 4x make 16x. 13 and 7 would make 20 equals 180. Subtract 20, we get 16x is equal to 160 rather, and then divide by 16, and we get x is equal to 10, which is this one down here. So remember, alternate angles are equal to each other. Consecutive angles are adding to equal 180, and then corresponding angles, which we didn't necessarily show here, but corresponding angles which look like this. Let's actually go back here. So corresponding angles like these are also going to be equal to each other. So if you had a problem like this, and you had like 2x, and you had like 70, and they said find the value of x, then you would say 2x equals 70, and then you divide by 2 and get x is equal to 35. But corresponding angles are always equal to each other. Alternate interior angles are always equal to each other. Right, there you go. And then consecutive interior angles are always going to add to equal 180. So those are the rules for those type of angles there. All right. So the next one here. This deals with the sentences we did about contrapositive, converse, inverse, and all that stuff. So we have our if-then statement at the top. If Mr. Pauls is your math teacher, then bonus questions are weird. So we say that the if part, that's my hypothesis, so we'll call that P. And the then part, that's my conclusion, so we'll call that Q. So the contrapositive, converse, and inverse all deal with what you do with P and Q from the original. So the contrapositive means that you're going to swap P and Q and then negate them, which means you're going to put a not in front of them. So swap and negate is contrapositive. So that means I'm going to have if not Q, then not P. So if not Q, then not P. So if the bonus questions are not weird, that's how I'm going to start this. Let's see which one has those. If bonus questions are weird, that's not going to work. If Mr. Pauls is not your math teacher, well, that has the not, but I want not Q and Q, not Q. I don't want not P. So this one isn't going to work. If bonus questions are not weird, well, that's what I want, right? If the bonus questions are not weird, so that's not Q. So that's going to be one possibility. And then Mr. Pauls is your math teacher, if and only if. Now that's not going to work because it's not even an if then there. So that means that C has to be our one. Just by process of elimination. Whoops, let me try that again. Just by process of elimination, C is our answer. So if bonus questions are not weird, then Mr. Pauls is not your math teacher. So again, we have not Q first, and then not P second. So not end, not beginning. The converse is simply when you swap. So you're going to swap P and Q. So that means I'm going to have Q first, then P. So if bonus questions are weird, then Mr. Pauls is your math teacher. Well, that's right here. If bonus questions are weird, then Mr. Pauls is your math teacher. Okay? This is Q. This is P. They've been swapped. I'm good to go. Whereas this one was not Q. This one was not P, which is what I want for a contrapositive. For a converse, I just want Q and P switched. For the inverse is not P and then not Q. The mathematical notation would be squiggly P and squiggly Q. This squiggly means the not, but I'll use N just to make it a little bit more clear. So not P. Well, again, P is Mr. Pauls is your math teacher. So not P would be Mr. Pauls is not your math teacher. So I'm going to look for which one starts with that. Well, the only one that does that one is this one right here, so this one has to be it. So if Mr. Pauls is not your math teacher, then the bonus questions are not weird, which is the not Q there. So this is not P, not your math teacher, not Q, which is not weird. So converse, inverse, contrapositive deals with swapping for converse, negating for inverse, and then doing both for contrapositive. So contrapositive is the one where you do both of them. Everything else is just one change. The if and only if, this is called the biconditional. So biconditional. Con-D for conditional. So if they ask you what the biconditional is, that's when you're going to look for the if and only if. That's the oddball out, essentially. But everything else is an if-then statement. So now we're going to go back to the calculation bit of this here with the triangles. So we want to figure out the missing, or actually we just want to figure out what x is. We don't want to figure out the missing angle, just what x is, which is a key difference. So let's figure out what the missing angle is. So in a triangle, if you have all three inside angles, they're going to all add to 180. That's the rule for triangles. All three inside angles add to 180. So I'm going to have 72 plus 38 plus 6x plus 16 is going to equal 180. So once again, I'm going to go down and try to simplify my terms there. So I'm going to add together 78, 38, and 16. And that's going to get me, let's see here, 78 plus 38 plus 16 will get me 126. Plus 6x here, because I didn't mess with the 6x, equals 180. Then I'm going to subtract 126 from both sides. I'll get 6x is equal to 54. Then divide by 6, and I get x is equal to 9, which is what I have right there. So if you have all three inside angles, it's a 180 trick. You add them all together, you set it equal to 180, and then you solve it like you would an algebra problem. If you have the outside angle, this one's set up a little bit differently. These don't add to 180. The rule is that the outside angle is always equal to the sum of the two angles it's not attached to, or the sum of the opposite two. So you're going to add these together because it's the sum. So the two angles over here added together are going to equal the outside angle over there. So I'm going to have 92 plus 8x plus 5 is equal to the outside angle of 24x plus 1. This is called the exterior angle theorem. Again, if you're not going to remember it, something probably to write down on a note card. So I'm going to combine my like terms here. So 8x, 92 plus 5 is going to give me 97 is equal to 24x plus 1. Then I would subtract 8x from both sides just to get my x's together. I get 97 is equal to, let's see here, 24x minus 8 would give me 16x plus 1. Then I subtract 1 from both sides. We get 96 is equal to 16x. And then divide by 16. And 96 divided by 16 would give me 6 is equal to x. So that would be this one right here. So exterior angle theorem is outside angle is equal to the sum of the opposite two. So this angle plus this angle together give you the outside one. Let's see here. The next ones deal with stating the theorem that could be used to prove the triangles are congruent. So you don't have to go through the entire proof, but you have to remember that we have 5 ways this can happen. We have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. This is only, let's do it again there. I'll try to make that a little bit nicer. Angle, side, angle, 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 side, and hypotenuse leg. There we go. So this one is only for right triangles. So it's something that looks like this. You have to have the right angle in order to use hypotenuse leg. If you don't, it's automatically not HL. Like for this one right here, we can automatically cross out HL because there's no right angle. So you're looking for which one of these does it match up with, and if not, if it doesn't match up with any of them, then it's not enough information. So in this case, we have these two sides marked congruent. So we have a side pair, so I'll put a little S there. So we have a side pair. These two sides link up. We have an angle pair, so this would be an angle. So I have SA, so it could be either this one, or this one, or this one, because they both have a side and an angle, so they both use S and A. It's probably not SS, because I have an angle involved, so I'm not going to use SS, 3 S's rather. But I'm really kind of stuck right now, because I only have an S and an A. I don't have anything else. But if you look here, this side, this is our reflexive side. It's shared between both triangles. So that's your freebie. You can mark that as congruent even if they don't because it's shared between them. So this would be your third S. So you have 2 S's and an A, and the only one here that fits that is side, angle, side. Angle, side, angle requires 2 angles, which we don't have, but we do have 2 side pairs. One pair is here. Again, it's a side pair, so they come in 2s. So one pair is here, this side and this side, because they're both marked. Then we have the angle marked, so SA, because the angle is marked. And then we have the shared side is also given to us. Because remember, the shared side is going to be congruent between the triangles, so that gets us our freebie. So label the stuff you have in your diagram and figure out what arrangement best fits that. So down here, again, there's no right angle marked, so we can automatically cross out HL because that's not going to happen. Right now we have a pair of sides, so I'll write it on this triangle here. So this is a side. And we have a pair of angles matching, so we'll do A. If you want to write them in both, you can. I would just prefer to write it in one just so it's less for me to do. But once again, we're kind of stuck. We don't have any other markings to go off of. But what we have to realize is that this right here, this is an X pattern, right? So if you have an X pattern, that means this angle and this angle are going to be equal. So this is my second A there, because I have another pair of angles I know are congruent because they're vertical. So these angles are congruent because they're marked, these sides are congruent because they're marked, and these angles are congruent because they're vertical. They didn't mark them for me, but I have to kind of know that intuitively. So the question is, do we have angle, angle, side, or angle, side, angle? So it's a angle, angle, side, or angle, side, angle. Now here there's only one choice, so obviously we know what it is. But just in case you had both options listed and you're not sure which one, the way you can tell is if you can get from one A to the other without crossing the S, then it's angle, angle, side. So like in this case here, I can get from this angle to this angle without crossing over the S. If I can do that without again going over anything that's not marked, if I can do that, then it's angle side angle because the S is not between the two. What this one would look like, or sorry, angle angle side, my bad. What angle side angle would look like would be something like this. If I have a similar diagram, if I was given these angles here, this side here, and these angles here, this would be angle side angle because the side, the S, is between the two A's. So here's my A, here's my A. The S is between the two A's, so therefore this would be angle side angle. In this case, the S is not between the two A's. Between them is nothing. So there's no S mark there, there's no mark there. So this is angle side angle because the S is not in that line there. I can connect A to A without going over the S. So make sure you know these 5 diagrams here. Again, side, side, side is simple when you have 2 triangles and all 3 sides are marked. So here's marked, and there's marked. So that would be side, side, side. Again, we just saw side, angle, side there, and we just saw angle, angle, side there, and then angle, side, angle would be this one right here. Again, HL is when you have a right angle involved, so if you don't see that, it's not going to be HL, so you can automatically throw that away. All right. And then in this case, we're solving for the triangles here. Again, we're solving for a missing angle. These are special triangles in that, again, their diagrams are giving you information that's not explicit. So in this case, we say that all 3 sides are congruent. Well, what you have to know is that if all 3 sides are congruent in a triangle, that means all 3 angles have to be congruent as well. So if all 3 sides match up, all 3 angles match up. Well, if all 3 angles match up, that means this angle and this angle are the same. So I can say that 60 is equal to angle 2, which we say right here is 5x plus 5. So I can set up this equation here and then solve for that. So I can subtract 5 from both sides. I get 55 is equal to 5x. Then I can divide by 5 on both sides, and I get 11 is equal to x. So if all 3 sides are equal, that means all 3 angles have to be equal as well. So you'd set up an equation like this, and you get that x is 11. So 3 equal sides means 3 equal angles. What if you only have 2 sides equal though, like this one here, that and that? Well, if you have 2 sides equal, that means the angles opposite them, so this angle here, you can draw your arrows to help you out, this angle and this angle, those 2 are going to be equal. This third one's not going to be. This third one's not going to be equal to the other 2. But these 2 angles are definitely going to be equal. So 67 is going to be equal to angle 2, which is x plus 73. Which I can then solve for by subtracting 73 from both sides. And I get that negative 6 is equal to x. Now, some of you might be saying, well, you can't have negative 6 as an angle measurement. An angle can't be negative 6 degrees. And you're right. But this angle isn't negative 6 degrees. The x is. But if I plug this x back in here, negative 6 plus 73 is going to give me 67. So this angle is still positive. The x is negative, but the angle itself is still positive when you plug the x back in. So it's okay for your x to be negative as long as your angles and sides are not negative. So that was special triangles there. Equilateral triangles, which this one's called, and isosceles triangles, what this one's called. The other type of triangles we dealt with were right triangles, and this is where we're going to use the Pythagorean theorem. So this is your a squared plus b squared. Whoops, let me get rid of that. Try to undo that there. There we go. This is your a squared plus b squared equals c squared deal. So remember, in a right triangle, C is always the angle that's opposite the right angle. So if you see your right angle, draw an arrow straight across, and that arrow points to your C. Just like right here, I'm going to draw an arrow straight across. This points to my C side, so this one right here. So in this case, I'm missing my C. So what I'm going to do is I'm going to write out my formula. A, B, and then this side here is C. So A squared is 8 squared. B squared is 11.8 squared. So that's a point there. And then x squared is just x squared. Okay? So c squared is just x squared. So a is 8, b is 11.8, and then c is just x. So I just replace them with the values. And then I go through my list. 8 squared is 64 plus, and then 11.8, whoops, let me show this on here. 11.8 squared is just 139.24. 139.24 is equal to x squared. Then you're going to add them together. So 139.24 plus 64 is going to give me 203.24 is equal to x squared. Now you wouldn't stop here because that's not an answer. You would have to square root both sides because you want x. You don't want x squared. So you'd put x down here and then you'd square root both sides. So it'd be second square root 203.24, which would give you 14.25, which would be rounded up to 14.3 because the 5 makes the 2 go up to a 3, so that'd be the one you have there. So this is a case where you're missing your hypotenuse, you're missing your C. The other case here is when we have the hypotenuse. I'm going right here. We have my C value. I'm missing either my A or my B, whatever one you want to call this. So if we label this here, this would be A, B, C. So if we use this formula here, A squared is x squared, B squared is 5 squared, and C squared is 13.5 squared. So what we would do then is we would do the same thing as before. We'd square our numbers first. So x squared plus 25 is equal to 182.25. Now instead of adding, because our numbers are on opposite sides, we're going to subtract 25 from both sides because they're on opposite sides of the equation. So here, my numbers were on the same side, so I added them together because they're on the same side. If they're on opposite sides, then you subtract. Again, think of subtracting as disagreeing. So if they're on opposite sides, they disagree, so they're going to subtract from each other. And it's going to give you 157.25. And then we're going to square root both sides. And we end up with x is equal to 12.5, which is accurate. And a way you can check yourself on these is that the rule for the hypotenuse of a right triangle is that the hypotenuse always has to be the longest side. So in this case, 13.5 is longer than 5 and it's longer than 12.5. So it is the longest side, so that's good. That means my number is probably accurate. In fact, because of this, I could automatically cross out A and C. A and C automatically can't work because they're both bigger than 13.5, and that can't happen. And then over here, again, my answer of 14.3, that is bigger than 8, and it's bigger than 11.8, so that answer is going to work because, it's bigger than both. You could automatically cross out 8.7 because 8.7 is not bigger than this one. So the only numbers that would have worked would be one of these three anyway. So you can use that as kind of a common sense check to make sure that your answer makes sense and that you didn't make a wrong turn somewhere. If you fail that check, if your answer doesn't match up with that rule, then it probably means that you added or subtracted when you should have done the opposite. So if you added and you check your answer and it doesn't work out, that means you want to go back and subtract in this middle step here instead, and that will probably fix it. Not always, but most likely. So last part here we come to is the proofs. So let me draw my 2-column setup here. We all know how this goes. So we start with our given. So our given is just this mess in here. So all this stuff we would write as our given, and we'd say given. And then we're going to try to figure out how can we prove these triangles are congruent. And again, if you want to prove 2 triangles congruent, you have your 5 options: S, 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 A, S, angle, angle, side, and HL, and then angle, side, angle. I almost missed that one. Angle, side, angle. So you have these 5 options that you're trying to get to from your given statement here. Let me make that a little bit better there. So over everything, make sure I include those sides there. So let's mark down what we have first. So it says Q is the midpoint of PT and RS. So Q right here is the midpoint of these lines here. Well, if Q is in the middle of, let's say, PT, if Q is in the middle of PT, that means PQ has to be equal to QT. So PQ has to be congruent to QT. Because if Q is in the middle, that means the first half has to be equal to the second half. Otherwise, it wouldn't be in the middle. And that also holds true for RS. RQ is the same as QS. So RQ, we'll put that on the same line here. RQ is congruent, make a Q there, is congruent to QS. Because Q is in the middle of that as well. It says it's the midpoint of both. So both of these are true by the definition of midpoint. So if you have definition of midpoint, that means you should have 2 segments, this one and this one, 2 segments congruent to each other. Same here, 2 segments congruent to each other. And usually, the way you would label them is you go, if you notice here, PQ and then QT. So the ending letter of this one is the starting letter of that one, because normally people see it as P to Q and then Q to T. So if you see that little notation of ending here is the same as starting there, that's a good indicator that you got it. There's also different ways of labeling this. You could say QP is the same as QT, but again, this might be a way you want to write it so you can check your work there. So I have 2 sides. So these 2 are looking good. I have 2 sides. But I either need a third side or I need an angle to help me out here. So in this case here, we should notice that once again, we have this sort of X pattern in the middle. So if we have this sort of X pattern in the middle, that means that this angle and this angle are going to be congruent because they're vertical. So I can say that angle, now remember, when you're labeling an angle, you need 3 letters. So angle PQR. I'm going this way, PQR. So PQR is congruent to angle, and then here is SQT. So SQT. And this is by definition of vertical angles. So vertical angles are always equal or congruent to each other. So now I have 2 sides. So here I have an S and an S, 2 sides, and I have an angle. Well, the only one that fits that there is side, angle, side. So I have a side, an angle, a side, side, angle, side. So I'd say that triangle PQR is congruent to triangle TQS by side, angle, side. Again, your proof statement should always be your last, and your given should always be your first. So in any proof, you automatically know how you're going to start and how you're going to finish. It's just the middle that we need to think about. And again, when you're trying to prove triangles congruent, you're trying to get one of these 5 cases. And if they don't tell you anything about perpendicular lines or anything about right angles, HL is probably not the one. Again, HL is very specific, so if you have to choose one to try to go to first, avoid HL. Try to get the other ones. If all the other ones don't work, then maybe look at HL at the end. But in this case here, I was able to use midpoint to get 2 sides, and then I was able to use vertical angles to get my angle, and that allowed me to get side angle side. So always look for your, in your given, look for things like midpoint or bisectors or stuff like that, because midpoint and bisectors tell you that things are going to be equal. Midpoints cut segments in half, bisectors cut segments or lines in half. And again, past homeworks and quizzes and stuff have used those as well. Speaking of which, we have a bisector right there. So let's see how this works. So once again, let's go ahead and set my lines. Let me use the line tool here to make this a little bit neater. So there and there. And we'll start here. And we'll try to just do a few here. I'm not sure how much this is going to take here, but we'll just put a few just to be on the safe side. And once again, my entire given statement, this entire thing here, is going to be first. And why is that true? Well, because it's given to me. So it says AC, so this line right here, AC, bisects these two angles. So let's outline these first. BAD. So BAD. BAD is bisected by AC. So this red line's the bisector. Remember, bisect means to cut in half. So split into two equal pieces. So, excuse me, if BAD is split into two equal pieces, that means that the top piece, BAC, has to be equal to the bottom piece, CAD. So it's a BAC, this top piece, BAC, is congruent to the bottom half, CAD, this bottom angle right here, CAD. And why is that true? Well, by definition of bisector. Bisector, there we go. So whenever you hear the word bisector, think, okay, something is being cut in half, and the something is whatever comes after the word. So AC bisects BAD. Well, that means BAD has been cut in half, so I should be able to get two angles out of that. Bisecting an angle means you get two angles out of it. Now it also bisects BCDs. Let's go to that round here. So it also says that this red line here bisects BCD. So BCD is this angle right here, which again means the top half is going to be equal to the bottom half. So this top half is BCA. So BCA is congruent to the bottom half, DCA. So DCA. And this again is by definition of bisector. So if you want to write that down again, you can, or you can use ditto marks, which is just this. Looks like an 11. But this just means take the reason above it. So definition of bisector, and then definition of bisector again. So if you bisect two angles, that means you have two pairs of congruent angles you can get from that. Now, unfortunately, this doesn't help me too much yet because I have two angles, but I'm going to need at least one side. So the things I have two angles are angle, side, angle, and angle, angle, side. Let me erase this red line here. So right now I have two angle sets. I have these two angles equal, and I have these two angles equal. But I still need a side either between them or outside them in order to use one of these here. And unfortunately, I don't have any more given to me. So I'm going to go to my diagram, and you should see that AC here is shared between the triangles. And anytime you have a shared piece, that's basically a freebie, because this piece is equal to itself. AC is obviously the same as AC, like 5 is the same as 5. AC is the same length as AC. So therefore, what we can say is AC is congruent to AC. Why? Because of reflexive. Again, think reflection. Reflexive. And again, the reason we mark this down is because it's a shared piece. Because now I have two angles. I have an angle here, I have an angle here, and I have a side. So I need to figure out which one of these is it. Is it angle, angle, side, or angle, side, angle? Just because they're labeled this way in my proof doesn't mean they're going to fit this way in the end. For that, you have to look at your diagram. So my diagram, if I take this top triangle, I have an angle here, I have the side there, and I have the angle there. So these are the stuff that I've marked. I've proven this angle is congruent, I've proven this angle is congruent, and I've proven this side is the same or congruent to itself. So in this case, if I try to go from this A to that A, if I try to connect my A's with a straight line, I have to cross over my marked side. I have to cross over my S. So that means that we're going to have angle side angle instead, not angle angle side, because this means that I can connect my A's without going across the S here, which I can't. So I would say that triangle ABC is congruent to triangle ADC by angle side angle. Because again, the reason is in order to connect my two angles, I have to cross over the S. If I have to do that, that means it's an angle side angle problem. The only way this would be different would be if somehow I was either given or could prove that, let's say, instead of the middle one, let's say we proved that this side was congruent to that side. So then my S would be over here. And then I could connect my two A's. So these right here, I could connect my two angles without crossing my S. So this would be a case of angle angle side, because I connect my A's without crossing over my S. But I didn't have that. What I had was I had that my side was here in between the two angles. Make that again. There we go. My side was here in between the two angles. Put an S there again. So I had to, again, use angle side angle instead. So your proofs are going to be on proving triangles are congruent because those require the most work in a sense. And again, it's going to be using one of these 5 notations here. So these are going to be pretty important both for these problems and for, if we go back here, and for these problems. So these problems are just basically saying, I'm going to give you as much information as possible. You just tell me which one of these 5s would work. You don't have to prove it. Just tell me which one of these 5s would work. So those problems and your proofs, you're going to need to be familiar with these. So this would be definitely something to put on a note card and maybe diagram what each one would look like. So again, side, side, side looks like this. Side, angle, side looks like this. Angle, side, angle looks like this one down, or sorry, angle, side, angle looks like the one we just did. So that was when you have 2 triangles and you have angle, side, angle, angle, side, angle. So you have the side in between the 2 angles. And then angle, angle, side would be this one down here, where you have the 2 angles not interrupted by a side between them. So that's it for this video. Again, kind of a long one, I know. Most of the stuff is, again, making sure you know rules and formulas and the way things relate to each other. So more than enough information to put on a note card, so make sure you use that wisely. Hope you enjoyed the video. Good luck on your final. Have a good day.